will be closed. Now coming to in this, what we will discuss, IC packaging considerations, package fabrication technologies, different type of package fabrication technologies, special considerations, what all we have to give. Now, while designing a package, we should give importance to smaller footprints. Footprints means what? We are having integrated circuit. What is there inside that integrated circuit? I may design C amplified circuitry. You may design multi-stage amplifier. Okay, my design is voltage amplifier. Your design may be power amplifier. So on that IC, what we are going to design? So that is footprints, whether that circuit is fabricated correctly in that die within that square, whether it is designed correctly. Okay, those are smaller footprints. And then nowadays we know all the devices are becoming handy. So handy means power battery supply is required. Okay, battery provision should be there. When battery provision is there, we should also take care how much power dissipation is going on. So high power dissipation is not our requirement. We should see that minimum power dissipation should take place, because it is operating with battery, it is handy in nature. So we should also see it is power effective, minimum power utilization, minimum power dissipation. All these things we should consider while doing this smaller footprints on the top of IC or die. Okay, and then these are different examples. Metal oxide semiconductor, field effect transistors, all these are part of that integrated circuit only. So what circuit? I am going to design voltage amplifier where transistor is present. You are going to design power amplifier. You may do it with MOSFET. Okay, I may do it with BJT. You may do it with a MOSFET. So all those things we should take care. Next, VLSI design rules. So while doing this IC fabrication, there are some design rules. You cannot do as you like. If one single transistor to be fabricated, there is some dimensions. Within that small dimensions only one transistor should be placed. All these are called design rules. From the schematic to layout. Okay, schematic means we draw the circuit in a software. Layout means we are going to make it into a practical version, which means the hardware design is going to take place. Okay, hardware design is going to take place. So for that, there should be a proper matching between schematic diagram drawn. You have done it in DSD, digital system design. You are doing coding. Okay, Verilog coding. After that, you are dumping it in the FPGA kit. For what? You are doing the coding, which is software level. Then you are taking it into hardware. So that matching should take place. You are writing test bench. Okay. So with the minimum test bench, with minimum test vectors, the entire design should be checked, and it should say whether it is properly functioning or not. Then only it should be taken to hardware. Hardware matching with the software should correlate. Okay, if you write the coding something, it is giving error in the hardware, that is not proper design rule. So design rule should be connecting the schematic as well as the hardware. Okay, and layout, schematic and layout, which is Verilog coding and the FPGA hardware. So like that, there are design rules. I told you about MOSFET. There are many rules for AND gate, OR gate. What is the dimensions? How many IO pins are there based on that square? Okay, I told you 12-inch wafer, 18-inch wafer. In 12-inch wafer, the die size will be small, and in 18-inch wafer, each IC or the die dimensions will be little bigger. So based on that, how many IO pins should come out? Okay, and when we are making the device handy. When we are making the device handy, what actually we are doing, we are compressing a bigger circuit in a smaller version. How the mobiles have become so handy. Earlier computer used to occupy a big room. In a decade back or 2 decades back, one computer will occupy a big room. Now computer is very handy, isn't it? So how that dimension reduction has come, but we are compressing the components in a smaller area. So for doing so, we are also decreasing the interconnects between them. There are many components. When those components are connected, the connection lines length is also reduced. Okay, so we are making everything in a small area, and we are increasing speed also. Okay, we are getting advantage by compressing. So a lot of background effect is there, which should be properly maintained. Only then we will get this advantage. Because the size is reduced, performance is not reduced. Performance is opposite, increasing. Okay, so there is a lot of background effect which are called design rules, which should be followed to get advantage of all these things. Next step, in the software, for doing all this, before practically bringing out the mobile, what the Samsung, Intel, Apple, all these companies are doing, they test it on a software version. Then based on the results only, they will go into practical implementation. While doing practical, lot of cost, okay, is involved. So directly they will not go and try real time. It will be wastage of resources and money. So they will first test it in a software version. If the results is almost to the expected level, then those things only they will go to fabrication. So like that, for software testing, the CAD tools can be used, VLSI designer can be used. In our VLSI lab, we have Cadence, and we have other softwares also, TCAD, Xilinx. All these are software versions of testing the basic design. Okay. Now, length of focus, it is number of spaces into pitch. Pitch means the holes, what are the ups and downs which are present. So first one, design rules, okay, smaller footprints. Second one, power density. As I told you, how much power is dissipated, those things we have to take care. The power dissipation should be minimum because the devices are becoming handy. That comes under power density. Thermal efficiency. Thermal efficiency means power dissipation is there, okay. Heating is going on. When the transistor gets heated, what we are doing, heat sink should be provided. So that heat sink, okay, based on the size of, what is the IC size? Big size means big heat sink. Small size means small heat sink. So all these things will come under thermal efficiency. So power dissipation comes under power density. And these are examples, solar inverters, power supplies, all these things are there. Thermal efficiency, I told you, how far the temperature heating, what is done, it is able to handle whatever packaging you are giving, how far it is able to handle the heat that is created in the IC. Okay. Now, this thermal efficiency, it is analyzed in terms of thermal resistance, overall thermal resistance. Here you have a formula, thermal resistance between junction and to the ambient. Junction to the ambient equal to thermal resistance between junction to case, thermal resistance between case to ambient. Okay. So thermal to case means from the junction to case means from the junction to surface of the wafer. Then here from the surface to ambient. Okay. So the units for thermal resistance is degree centigrade per watt. And how this thermal resistance is measured, you can see the difference in temperature divided by the power dissipation that is taking place. Okay. From the junction to the surface of the vapor, the difference in temperature in interior to surface. What is the difference in temperature divided by the power that is getting dissipated, temperature by power, that is thermal resistance. Similarly, from the case, which means surface of the wafer, to ambient, what is the temperature difference divided by the power dissipated. So these two parameters are used in the calculation of overall thermal resistance. And fourth point, heat dissipation. First one is smaller footprints, second one power density, third one is thermal efficiency. Now the fourth one is heat dissipation. It is also more or less the same. You can see here IGBT means insulated gate bipolar junction transistors. Okay, bipolar transistors. So insulated gate bipolar transistors are there. How about the heat dissipation taking place, and what is the provision we are giving using this packaging method for reliable operation? Okay, so for proper operation of the entire IC, what is the facility we are giving through packaging process? Next, electrical considerations. So we are having IC, everything okay, it is good. How it is favorable for the electrical connectivity? Okay, so all these things, any spikes are coming out, so any signal runs, any grounding is done properly in the IC. So all these things will be taken care. And what is the operation frequency? All this will be taken care by giving electrical considerations while doing packaging. Sixth one is mechanical consideration. Mechanical means already I told you how we are compressing it inside the box. Okay, what is the material thermal coefficient? Material used in the packaging, what is the thermal coefficient of expansion? In summer, whether the box will expand and give facility for the interior IC present. And similarly, finite elemental analysis. Final elemental analysis, this is the procedure used for handling these mechanical considerations. Okay, so first one is smaller footprints, second one power density, third one thermal efficiency, fourth one heating dissipation, fifth is electrical considerations, sixth one mechanical considerations. The 6 considerations should be done while doing